In March 2020, we were forced to isolate due to COVID. Without being able to see our friends and family, we resorted to FaceTime and online platforms to talk and stay in touch. Playing cards has been one of the biggest platforms for hundreds of years, but with COVID isolations in the past and now great distances separating loved ones due to different career paths, travel, and more, it's becoming increasingly more difficult to sit together and play cards. We are now forced to play online card games or just resort to not playing cards at all, leading to a loss of card game authenticity and less time spent with loved ones. Current options to play cards are purely virtual. However, today, we at Jack of All Trades are introducing our new product. With this product, we are giving everyone the opportunity to play games with physical cards with their friends and family, no matter where they are. Each person just needs to have our device, an outlet, and a connection to Wi-Fi, and they will have endless opportunities to play card games with their friends while getting to feel the actual cards and without having to face the limitations of online card games. At this time, for the scope of our project, we've implemented GoFish. At a high level, our device consists of 5 primary parts. First of all, to get the actual feel of playing with physical cards, we have a thermal printer, which will deal the cards to the user based off of the game state. We then also have a 10-key keyboard, which will be used to take input from the user when necessary to update the game state or play their move. Next, we have an LCD screen, which will display the current state of the game, as well as indicate any requests or calls of action. Then, we have a camera pointed over the playing area where users can place their cards, which will be detected and update the game state. Finally, to control each of these pieces, they will all be connected to a Raspberry Pi. We will go over each of these functionalities in more detail next.
The first part of the device is the thermal printer. We have designed our own cards to replicate actual playing cards by creating our own bitmaps of the different suits and ranks. Each card will have its ranks and suit in the top left corner and bottom right corner. Examples are shown on the screen. This printer is connected to the Raspberry Pi, so we can send commands to the printer directly to deal out a certain amount of cards. Each card takes approximately between 4 and 7 seconds to print out depending on the complexity of the card design. Users are then required to rip out the card and place them on the cardstock so that they can hold the receipt similar to how they hold actual cards. An important part of the game is to be able to see what other players have done, what cards they have placed down, and when it is your turn to move. In order to show these, we opted for an LCD screen, which has the primary functionality of displaying all these needs. When the game state is updated, the LCD will appropriately also update with information about what another player has played. It will indicate to you when it is your turn to play a card or give further instructions on what to do. It will also actively show what the user enters into the keypad, which will be described next.
This keyboard's purpose is to take in additional input from the user when necessary. This can include actions such as requesting cards. For example, in GoFish, if you want to request a 6 from another player, when prompted by the LCD screen, you would enter in a 6. The keypad has the ability to enter in any number and any suit as needed. In the game GoFish specifically, you will only ever need to request a number from 1 to 13, where 1 indicates an ace and 11 to 13 will indicate jack to king. Your inputs will be immediately displayed on the LCD screen so you can see what you have requested.
The next part is to be able to detect the cards that a user plays and be able to update the game state. To do this, we have a camera that is angled above the entire device to capture the playing face, where users can place their cards when they would like to play it. The camera is connected to a computer vision and machine learning algorithm called You Only Look Once, or YOLO for short, version 8. This algorithm was trained on our custom cards dataset that were augmented and transformed in almost 3,000 ways to create a comprehensive dataset. When cards are placed under the camera, the algorithm creates bounding boxes around the objects and then utilizes the algorithm to detect which card it is. This algorithm has a 99.5% accuracy of detecting cards. Once the cards have been detected, this information is sent to the back end where the game state will be updated. There's also logic here to ensure that the card that is being played is a legal card that was in the user's hand, as well as is a card that can be played according to the game logic.
So now when a user puts down a card, it would trigger the detection. It detects accurately the card which is put down by the user. If the user puts down a second card, and we run detection, it accurately detects multiple cards.
So on the Raspberry Pi, each of these devices that we've talked about so far is running on its own thread. And they're all listening to whatever peripherals or to the protocol in order to respond to any inputs or messages and keep the device running. The architecture for the device is such that it is a dumb peripheral. And so it doesn't do any local computation with respect to the game that's being played, other than our machine learning model. It runs detection on it. So in order for the device to communicate with the server, we're using the SerDes Rust package, which allows us to serialize and deserialize Rust objects to be sent over the network. So essentially, we have some enums which describe our protocol, and the package is able to serialize and deserialize these, so it integrates very smoothly with our software. As for the server, this is where all the game logic is being run. It runs continuously and accepts requests from TCP sockets from all the devices. And currently, there's just one lobby, but if we were to make this system larger, then it would have support for partitioning the devices into the lobbies and executing the games for each of these lobbies independently.
So this was our project Jack of All Trades. Thanks for watching.